Welcome back friends to yet another lecture. Today we are going to see the two fundamental laws of engineering mechanics. First one is addition of vectors, or rather parallelogram law of vector addition as commonly known. So if you see, it is a simple law that allows us to understand how vectors are getting added up. So here you can see that the sum of the two vectors p and q is obtained by attaching the two vectors to the same point A and constructing a parallelogram using p and q as the two sides of the parallelogram. The diagonal that passes through A represents the sum of the vectors p and q. Since the parallelogram constructed on the vectors p and q does not depend upon the order in which p and q are selected, we conclude the addition of the two vectors is commutative. That means p plus q is equal to q plus p. Let us consider a small table. Okay. There are two brothers who are playing around, and these kids' mother told them to move this table from this position to directly the other side over here. So the elder brother started pushing this table like this with the force of F1, and the younger brother started pushing the table like this in this direction with a force F2. So where do you think the table will end up? Do you think that the table can go all the way from here to here? No, rather it is going to end up somewhere here. Why? Because these two forces act together on the table and the table moves in a direction like this. So how to understand the resultant force of these two forces? So to understand the resultant force, we need to understand the parallelogram law of vector addition. So for that, let us consider the elder brother's applied force here F1 and the younger brother's force that is applied here F2. Now to get the resultant of these two forces, I need to construct a parallelogram, and what I am going to do is I am going to create the same length force here. That is, over here I will just make another force vector, and same way at the tip of this force I start constructing the F1 force length. So this is equivalent to F1 and this is equivalent to F2. Now the resultant of these two forces will be the diagonal that connects these two corners. Now look at this carefully. I have connected from this point to this point and not from here to here. So how to identify that? It is very simple. Rather, you just have to keep the tail of the two forces together and the head of the two forces together, join those 2 points, you get your resultant force R. Now you have a similar law which also comes into play here, that is nothing but triangle law. So in the triangle law, what you do is you keep the first force like this, say let me take the first force to be F2, and then you have the next force like this, say F1. So the resultant would be like this, R. Now, how to remember this law? It is very simple. You keep this force F2 like this, and then at the head of the force F2 I have placed the tail of the force F1 and I have constructed it. So you see here, this is the direction of flow. So the resultant will be from the tail to the head. So this is the tail of F2 and this is the tail of F1. So this is known as parallelogram law, and this is known as triangle law. Now, what if I add F1 and then F2? Okay, let us try that. Now, let us consider F1 is the first force that is added, F1, and on top of that you are going to add your second force F2. The resultant would be from the tail to the tip, as mentioned here, and to my surprise I find that both these end up in the same resultant force. So the law of commutative addition is proved here, that is F1 plus F2 is equal to F2 plus F1 is equal to the resultant force R, which is clearly depicted here using these two triangle laws of vector addition. Now let us try to see how more than two forces can be added. For this case, let us consider three forces. Let this be the force F1, then you have the next force F2, and then you have the third force F3. These forces are acting about an axis. Say, let me consider this as the axis line. These forces are acting at different angles, and let us define this as theta 1, this to be theta 2, and this to be theta 3. So in that case, how do we add these vectors? We can go ahead with the Polygon law of vector addition. Now, what is Polygon law? To understand that, let me put each of these forces one after the other on the head of the other one. Let us consider here the force F1 acting at an angle of theta 1. Then I have the force F2 that I will place in the head of F1 like this. This force is F2, and I have the third force F3 like this. So the angle at which this force is acting is theta 2 and this force is acting is theta 3, which corresponds to these angles. If I want to find the resultant of these vectors, I have to join from the tail of this F1 force to the head of the F3 force. So it would come like this. this is your resultant R, and the resultant R is acting at an angle of theta R. This is how you find sum of more than two forces. And if you see here, I can always use the triangle law one after the other. To apply the triangle law one after the other, let me say I add the force F1 and F2 first. So that is like this, F1, and at the head of F1 I keep the force vector F2, and the resultant is like this. Say this is a temporary resultant, so I will name that as RT, that is temporary resultant. Now the sum of this temporary resultant plus this F3, that is again yet another triangle law, will fetch me my R. So in total, the idea which I would like to convey here is that F1 plus F2 plus F3 is equal to F1 plus F2 plus F3, and which is also equal to F1 plus F2 plus F3. So all these three are going to fetch the same resultant R. We have understood how the forces can be added vectorially. This is a graphical method which you can use to find the forces. And as I have already mentioned to you, this graphical method is one of the easiest way to find the resultant of forces. And how you can do it? It is very simple. I have to fix on a scale which is suitable for drawing. Say for example, let me define that 10 Newton is equal to 1 centimeters. So in that case, say suppose if F1 was 50 kilonewton, I will draw this vector at the given angle theta 1 for a length of 5 centimeters, which represents 50 newtons. Similarly for F2, if it was 60 newtons, I will draw a line of length 6 centimeters, and similarly for F3, say if it was 35 newtons, I would draw a line of 3.5 centimeters. I will not tamper with the theta angles. The theta angles would remain the same. The scale must be uniform, that is, the scale that I use for F1 should be used for F2 and for F3. Finally, you just have to measure this resultant force R using a scale to find the total resultant force, and that when you multiply it with the scale, you get the answer. That is the simplest way to find the graphical solution of resultant of force. Now what if we want to subtract a force? Say I have a force vector F1 and I have another force vector F2. Suppose the resultant that I want to find is F1 minus F2. How to go about this? In vector addition, you do not have subtraction of vectors, you only have addition of a negative vector, which implies F1 will be added with a negative F2. Now don't you get confused with this negative F2. The negative F2 just represents the same force F2 in the opposite direction. The negative sign only represents that the direction changes. So in this case, I just have to add these two vectors now. So for that, I will use my force vector F1 again, F1, and I have to add the negative F2. So, I shall add it like this, F2. So, what am I finally finding out? The resultant. The resultant would be, as I have already mentioned, from the tail to the head. This will be your resultant force R. The vector subtraction is nothing but addition of a negative vector or a direction changed vector. Now, let us see the next important law as far as engineering mechanics basics are concerned. The next important law that we are going to see is the force transmissibility. What is force transmissibility? I would take the same example which I have taken earlier. Let us consider the table where two brothers were playing. Now, the elder brother decides to push the table like this with a force F1. The law of transmissibility is very simple. You can move this applied force along the line of action of this force. You can move it along the line of action of this force anywhere and apply on the same body, it will have the same effect. So, that means if I apply a pull force here of the same magnitude F1, this or this will result in the same effect of moving the table from this position to any other position. If I apply a force F1 here, that is a push force, if it is replaced by a pull force in the other side of the table, the net resultant effect is going to be the same. It is going to move in this same direction, if no matter you push or you pull the table. This law is known as law of transmissibility. So, this completes the basic fundamental laws upon which engineering mechanics has been built. Thank you.